The first thing we're going to look at is something called the segment addition postulate. And basically it's what it sounds like. It has to do with adding segments. So if I have 2 points A and C, so we want to start with drawing those 2 points, always label, and a third point B lies on that line segment, so I'm going to do B right there. Notice I'm not putting it specifically in the middle because it doesn't say anything about it being in the middle. If and only if AB plus BC equals AC. So what does that mean? AB is talking about this piece. So AB plus BC, this distance, needs to equal the total distance of AC. Which seems super common sense, but it is something that we have to show and talk about. And then basically we're going to use that idea to solve problems. So for instance, if I give you a segment and I set up the same way, if AB is 2 and AC is 12, what would that make BC? Well, it would need to be 10 because 2 plus 10 would give me 12. So let's look at some more complicated examples when I start adding in algebra. So example 1, if C is between D and E. So as soon as you get that, we're going to draw a picture. So C is in between D and E. Notice it's not always alphabetical, so don't just line them up alphabetically. And DC is 1/2 times 4x plus 6. So I don't like fractions, so I'm going to go ahead before I even label my fraction. So when you multiply or distribute by a half, you just want to think what's half of that number. So what is half of 4? That's going to be 2. So 2x. And half of 6 is 3. So now what I'm going to do is label that on my diagram. DC is 2x plus 3. And CE is 3x plus 1. And last, DE is a total of 44. So from there, I know that DC plus CE must equal 44. So we're going to write that as an equation and solve 2x plus 3 plus 3x plus 1 equals 44. And a little review from algebra. When we have things on the same side of the equal sign, we're going to combine like terms. So 2x plus 3x gives me 5x. 3 plus 1 gives me 4. And that whole thing is equal to 44. We undo the plus 4 by minus 4. So 5x equals 40. And then divide by 5, which gives us 8. So I don't need to see every single step of that. If you can do several steps in your head, that's fine. And one thing we always want to make sure when we're doing any problem, but especially these type of problems, is that you answer your question. So we solve for x, and at this point I reread the question. It says to find DC and CE. So what I do is I like to look at my diagram that we drew. So DC is 2x plus 3. So DC is 2 times x plus 3. And x was 8, so we're going to plug in 8. So DC is 2 times 8 is 16, plus 3 is 19. The next thing it wanted was CE. So CE was 3 times x, which is 8, plus 1. So that's 24 plus 1, which is 25. So I had 2 answers for that problem. Always make sure you answer the actual question. So we have a similar problem if B is between A and C. Sketch your picture. I'll draw it over here this time. So B is between A and C. And we have those lovely fractions again. So a fourth means we're just going to divide by 4. So a fourth of 16, 16 by 4 is 4. So 4x. 24 divided by 4 is 6. So I'm going to label AB with 4x plus 6. And label BC with 7x plus 15. And they give me that AC in total is 120. So this one is going to be set up the same way. We have the part plus the part is going to equal the whole. But sometimes they might give it to you so that you're solving for one of the parts, actually. 4x plus 6 plus 7x plus 15 equals 120. Combine like terms. 4x plus 7x is 11x. 6 plus 15 is 21. Subtract 21 from both sides. I think about that as it's 120 minus 21, so I take away the 20, which gives me 100, and then I need to take away one more, which gives me 99. So I'm going to bring that up here, so I get 11x equals 99, which means by dividing x equals 9. Is that what they asked for? Of course not. They asked for AB and BC. So AB, we're doing 4 times x, which is 9, plus 6. So 4 times 9 is 36, plus 6 is 42. BC is 7 times x, which is 9, plus 15. So that's going to be 63 plus 15, which is 78. So we've looked at the segment addition postulate. The next one is the segment bisector. So if you think about bicycle, that means you have 2 wheels, and so bisector means you are splitting it into 2 equal parts. So segment bisector is a line, ray, or segment that divides the line segment into 2 equal parts. So for instance, if I draw this diagram, if I have A and B, and we're going to draw a line, and I'll just put 2 random points, let's just call them X and Y. If that line is splitting them into 2 equal parts, and in math we notate the equal parts by these little hash marks, if you haven't seen that before. So we would say that in this case, line XY, so from yesterday, remember that a line, you just write the 2 letters of that line and you draw a little line with arrows over it. So line XY is the segment bisector of, R there, of segment AB. Remember, to do a segment, it just looks like a line without arrows, because that's really what a segment is, part of a line. So let's see what that looks like in problems. So it says EF bisects AD. So the segment that's being bisected is AD, and it's happening at point C. Let me draw that to the side. What they gave me that's bisecting it is also a segment, which isn't super, in this case, it's not super important about the EF and the actual naming, but we'll draw our diagram anyway. And I know that since it's bisecting it, that means that the two sides are the same. And now we're going to use that to solve the problem. So it says AC is 5x minus 8. So AC is 5x minus 8. And CD is 16 minus 3x. So this is different. We don't have what the whole is, so I'm not going to be adding them together and setting them equal to something. If I know that because it bisects that the two sides are the same, a symbol in math that means the same is equal. So we're going to set these two expressions, 5x minus 8 and 16 minus 3x, equal to each other and solve that equation. You'll notice another difference from the equations we were solving earlier is that now my x's are on opposite sides. So when they're on opposite sides, I need to do the opposite operation on one of them. So I like to move this negative, so I'm going to add 3x to both sides. If you're at the point you don't need to show all this work, that's fine. I'm just trying to show my work. So 5x plus 3x is 8x, minus 8 equals 16. And now we have a two-step equation to solve. So add 8, 8x equals 24, divide by 8, so x equals 3. And now what do we need to do? Actually answer the question. So the first thing it said was to find x. So I've done that. And now I need to find AD. Now there's two ways that you can think about finding AD. One is that you can add these two expressions together and then substitute in x, but a shorter way to do it is actually to just find AC, and since CD is the same length, I can just multiply my answer by 2, so I'm going to do it that way. 5 times 3 minus 8. So once again, I'm substituting in for AC, which gives me 15 minus 8, which is 7. So if AC is 7, that means CD is 7. So that means that the whole thing is going to be 14. So there are multiple ways to skin a cat. If you think about it differently and still get the answer 14, you are good to go. The next one is a super happy problem because it has fractions and decimals, oh my. So we're going to do that one in class. Don't worry about it right now. If you want to really be super impressive, you can try that one and show me your work and I will be like, whoa, that was awesome. But we're going to press the pause on that one and go on to our last one, which is the midpoint. And we're actually going to talk about midpoint twice in this unit. We are going to talk about it from points perspective, but then this one we're going to look at it in terms of expressions and variables and all that. So the midpoint of a segment is a point on the line segment that divides it into two equal segments. So that might sound super similar to what we just did. The difference is that a segment bisector is a line or ray or segment that's splitting up the line versus the midpoint is a point. So for instance, we might have this picture. So I have A and B and C is right in the middle. So we would say that C is the midpoint I'm going to abbreviate midpoint, of segment AB. So these will have pretty similar things to what we just did with the bisector. M is the midpoint of PQ. What do we always do first when they give me something like that? Draw a picture. So M is the midpoint of P and Q. PM equals 1/2 times 10x plus 16. So what are we going to do first with that? Because we don't like fractions, is simplify the fractions before we put in the problem. So half of 10 is 5x. Half of 16 is 8. So PM is 5x plus 8. And then it says PQ, so be careful where you're putting this one. PQ is 76. Find X and find PM. Well, I forgot to put one thing. No, I didn't intentionally. But we're missing one thing on our diagram. We started by saying it's the midpoint. So what does the midpoint mean? That these two pieces are the same. They're congruent. So if PM is 5x plus 8, that means that MQ is also 5x plus 8. And now we're back to the same type of problem we started with, where my two pieces, my two parts, add to give me the whole. So 5x plus 8 plus 5x plus 8 equals my total of 76. And we can combine like terms because the variables are on the same side. 10x, combine your 8s, so 16. You might also be thinking that really we could have just doubled the 5x plus 8. That's also totally fine. And subtract 16. And divide by 10. So I get x equals 6. Reread your question. It said find x. We found x. And now we need to find PM. PM. Okay, so PM was 5x. Our x is 6. 5 times 6 plus 8. 5 times 6 is 30. Plus 8 is 38. And last example. M is the midpoint of PQ. Draw your picture. If PM is 9x plus 3, yay, we actually don't have fractions in this problem. Everyone is doing a happy dance. 9x plus 3. And MQ is 11x minus 17. Find x and find PQ. So this one did not give me a total. So what am I going to do? Well, we need to go back to the fact that this is the midpoint, which means PM is congruent to or the same as MQ. And what operation, or sorry, what symbol can we put between these two that represents being the same? We would say that that means they're equal. So 9x plus 3, 11x minus 17 are equal to each other. And now we're going to solve the equation. Since my variables are on the opposite sides, I'm going to move one of these variables. I choose to move the 9x. I don't like dealing with negatives. My life advice, take it or leave it, is to always move your variable first. When you move your numbers first, you start getting confused. Just trust me. I've taught this a million times. Move your variables first, and you'll be a lot happier a lot more of the time. And then a two-step equation, so we're going to add 17, which gives me 20. And then divide by 2, so x equals 10. Reread the question. It said to find x, which we've done, and find PQ. So PQ is that whole distance. So I'm going to use the same strategy I did a couple problems ago, where I'm actually going to find just PM and then double that. So PM is 9 times x, which is 10, plus 3. So 9 times 10 is 90, plus 3 is 93. So I'm going to draw my diagram again just so we can see where this is coming from. So we have P, M, Q, and I just found that PM is 93, and since M is the midpoint, that means MQ is 93, and I can add those together, or I can multiply them by 2 if I like that method better, and get 186. So that's it. Make sure you snap a few pictures of your notes and submit them as a Google Doc. And make sure you press turn in so that I can check you off. Thanks.